Hello, weather watchers and cosmic explorers. Welcome to Did You Know, where we delve into the powerful phenomena shaping our world and beyond. Today, we're diving into hurricanes, those colossal storms that command Earth's atmosphere, and comparing them to their massive counterparts elsewhere in our solar system. Brace yourself for an exciting journey through the science and power of hurricanes, both terrestrial and extraterrestrial. Hurricanes, these swirling storms, are a spectacle of nature's raw power. They churn across warm ocean waters. They leave a trail of destruction in their wake. From space, they appear as mesmerizing spirals, but on Earth, they bring chaos. Imagine standing on a beach as a hurricane approaches. The wind howls, palm trees bend to their breaking point, waves crash against the shore with growing intensity. The sky darkens, signaling the approaching storm. This is the raw power of a hurricane. Hurricanes are more than just storms. They are complex weather systems. Warm ocean water fuels their growth. The Earth's rotation sets them spinning. These storms remind us of nature's delicate balance. Even small changes in our atmosphere can have dramatic consequences. When we look beyond Earth, we find that storms are a common occurrence. Jupiter's Great Red Spot is a prime example. This massive storm has been raging for centuries. It is larger than our entire planet. Saturn boasts a hexagonal storm that is a mystery to scientists. These cosmic storms share some similarities with hurricanes on Earth. They are driven by the energy within a planet's atmosphere. They exhibit swirling patterns of clouds and wind. However, they also possess unique characteristics that set them apart. By studying these distant storms, we gain a broader understanding of atmospheric dynamics. We can apply this knowledge to our own planet. The study of hurricanes on Earth and beyond helps us to comprehend the complex interplay of forces that govern weather patterns. The exploration of cosmic storms allows us to step outside our terrestrial bubble. Join us now on a journey. We will delve into the heart of hurricanes. We will explore their formation, their impact, and the science behind predicting their path. We will then venture beyond Earth. Our exploration will take us from the warm waters of the tropics to the swirling clouds of Jupiter. We will witness the destructive power of nature's fury. Get ready to be amazed by the power of hurricanes. Prepare to be humbled by the vastness of the cosmos. Let's begin our exploration of these awe-inspiring storms. Our journey starts now. Let the exploration begin. Hurricanes are born from a delicate balance of conditions. Imagine a vast expanse of warm ocean water. This is the first ingredient in our recipe for disaster. The ocean needs to be warm, at least 80 degrees Fahrenheit or warmer. This warmth provides the energy that fuels the hurricane's engine. As the warm ocean water evaporates, it rises into the atmosphere. This rising air creates an area of low pressure near the surface of the ocean. Think of it like a vacuum sucking up the air. Now imagine moist air from the surrounding areas rushing in to fill the void left by the rising air. This influx of moist air adds more fuel to the fire, providing more energy for the developing storm. The storm is starting to take shape, but it still needs one more crucial ingredient to become a hurricane. Birth of a hurricane. Enter the Coriolis effect, a phenomenon caused by Earth's rotation. As the Earth spins, locations at the equator move faster than locations closer to the poles. This difference in speed influences the movement of air masses, causing them to curve as they travel. In the case of our developing hurricane, the Coriolis effect causes the spiraling winds to rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. This rotation is a defining characteristic of hurricanes, distinguishing them from other types of storms. As the storm system continues to draw in warm, moist air, it goes through a series of stages. It starts as a tropical disturbance, a disorganized cluster of thunderstorms. Finally, when wind speeds reach 74 miles per hour or higher, the storm is officially classified as a hurricane. The Coriolis effect. A spin doctor. Let's delve a little deeper into the Coriolis effect, the invisible hand that sets hurricanes spinning. Imagine you're standing at the North Pole and you throw a ball directly south towards the equator. From your perspective, the ball travels in a straight line. However, to an observer on the equator, the ball appears to curve to the west. This apparent curve is due to the Earth's rotation. The same principle applies to air masses moving across the Earth's surface. In the case of hurricanes, the Coriolis effect is crucial for their formation. As this air converges, the Coriolis effect causes it to rotate, giving the hurricane its characteristic spin. The path of destruction. Once formed hurricanes are steered by global wind patterns and pressure systems embarking on a path of destruction. Predicting this path is crucial for mitigating the storm's impact on coastal communities. Factors like ocean temperatures, wind shear, and the presence of other weather systems can all influence a hurricane's intensity and direction. Meteorologists use sophisticated computer models and data from satellites, buoys, and aircraft to track hurricanes and forecast their path. These forecasts help authorities issue timely warnings and evacuate vulnerable areas, potentially saving countless lives. By unraveling the secrets of these powerful storms, we can improve our ability to predict their path and intensity. Hurricanes are nature's battering rams. They unleash ferocious winds that can topple trees, tear roofs from buildings, and turn everyday objects into dangerous projectiles. The sheer force of these winds, often exceeding 100 miles per hour, can transform a peaceful landscape into a scene of utter devastation. Imagine a wall of wind, howling like a freight train, slamming into a coastal town. Buildings shudder, windows shatter, and power lines snap like threads. The air fills with debris, a maelstrom of shattered wood, twisted metal and flying objects, each one a potential hazard. The destructive power of hurricane winds extends far beyond the immediate coastline. As the storm moves inland, it carries its fury with it. The aftermath of a hurricane's winds is a sobering sight. While the wind is the most visible and immediate threat from a hurricane, the storm surge and torrential rains it brings can be even more destructive. As the hurricane's low-pressure center approaches the coast, it acts like a giant vacuum cleaner, sucking water towards the shore. This surge of water, often several feet high, combines with pounding waves to create a wall of water that can inundate coastal communities. Inland, the heavy rainfall associated with hurricanes can cause widespread flooding. Rivers and streams overflow their banks, turning fields into lakes and swallowing homes whole. The combination of storm surge and inland flooding can leave a trail of devastation that stretches for miles. The floodwaters, often contaminated with sewage and hazardous materials, pose a serious health risk long after the storm has passed. The impact of a hurricane extends far beyond the physical damage. The economic and social consequences can be felt for years, even decades after the storm has passed. Businesses are destroyed, livelihoods are lost, and communities are torn apart. The cost of rebuilding after a major hurricane can be staggering, reaching into the billions, even trillions of dollars. Beyond the economic costs, hurricanes can have a profound impact on mental health. The trauma of experiencing a major storm, losing loved ones, or seeing one's home and community destroyed can leave lasting emotional scars. Hurricanes also expose social inequalities. These communities may lack the resources to prepare for a hurricane or recover from its impact, further exacerbating existing inequalities. The impact of a hurricane can linger long after the winds have died down and the floodwaters have receded. The memories of the storm, the loss, and the struggle to rebuild can stay with survivors for a lifetime. Each hurricane leaves its own unique mark on the communities it touches. Hurricane Katrina, which devastated the Gulf Coast of the United States in 2005, serves as a stark reminder of the long-lasting consequences of these storms. Even years after Katrina, many communities are still struggling to recover. Hurricanes are a stark reminder of the power of nature and the importance of respecting its fury. By learning from the echoes of past storms, we can build a more resilient future. In the past, hurricanes would appear on the horizon without warning, like specters of destruction. Coastal communities lived in a perpetual state of vulnerability, at the mercy of nature's fury. Today, thanks to advancements in technology, we have eyes in the sky, constantly watching, tracking and analyzing these powerful storms. Satellites orbiting high above Earth provide a global view of hurricane development. These sophisticated instruments capture images of swirling cloud formations, measure wind speeds, and even track the heat signature of a hurricane's core. Closer to Earth, hurricane hunter aircraft brave the storm's fury to gather crucial data. On the ground, radar systems scan the skies, providing detailed information about a hurricane's location, intensity, and rainfall patterns. The data gathered from satellites, aircraft, and radar systems are fed into sophisticated computer models that simulate hurricane behavior. These models, based on the laws of physics and decades of meteorological research, help scientists predict a hurricane's path, intensity, and potential impact. Predicting a hurricane's path is like forecasting the trajectory of a spinning top. Factors like wind patterns, atmospheric pressure, and even the Earth's rotation influence the storm's movement. Computer models take these variables into account, calculating the most likely track the hurricane will take. Predicting a hurricane's intensity is even more challenging. Despite the advancements in hurricane forecasting, predicting the exact location and intensity of landfall remains an imprecise science. Even a slight shift in wind direction or a change in ocean temperature can significantly alter a storm's behavior. When a hurricane threatens a populated area, every minute counts. Accurate and timely forecasts are crucial for emergency responders to evacuate vulnerable communities, position resources, and prepare for the storm's impact. Hurricane forecasting is a race against time, a battle to stay ahead of nature's fury. As soon as a hurricane forms, meteorologists begin issuing regular updates on its projected path, intensity, and potential impact. These updates, broadcast through various media outlets, provide crucial information to the public, allowing them to make informed decisions about their safety. In coastal communities, hurricane warnings trigger a flurry of activity. Residents board up windows, stock up on supplies, and make plans to evacuate if necessary. The hours leading up to a hurricane's landfall are a time of heightened anxiety and anticipation. Generate more accurate and detailed predictions. Another area of development is the use of unmanned aerial vehicles or drones to gather data from inside hurricanes. These drones, equipped with sophisticated sensors, can fly closer to the storm's core and for longer durations than manned aircraft, providing more detailed and frequent measurements. The goal of hurricane forecasting is not just to predict the storm's path and intensity, but to provide actionable information that can save lives and protect property. As technology continues to advance, so too will our ability to understand, track, and predict these powerful forces of nature, mitigating their devastating impacts and building more resilient communities in the face of the storm. We've explored the fury of hurricanes on Earth, those swirling tempests born from warm ocean waters and atmospheric instability. But our planet is not alone in experiencing these powerful storms. Across the vast expanse of our solar system, other planets are home to even more massive and enigmatic atmospheric phenomena, storms that dwarf even the largest hurricanes Earth can muster. Jupiter, the king of our planetary system, boasts the most famous of these extraterrestrial storms, the Great Red Spot. This swirling vortex, larger than our entire planet, has been raging for centuries, a testament to the immense power of Jupiter's atmosphere. Saturn, with its iconic rings, harbors a hexagonal storm, a geometric marvel that continues to puzzle scientists. Even distant Neptune, shrouded in icy cold and perpetual twilight, experiences massive storms, dark vortices that appear and disappear over time. These storms, while sharing some similarities with Earth's hurricanes, also exhibit unique characteristics, driven by different atmospheric conditions and planetary dynamics. By studying these cosmic counterparts to hurricanes, we gain a broader perspective on atmospheric processes, both on Earth and beyond. We learn how different planetary environments give rise to these swirling tempests, and we gain insights into the fundamental forces that shape weather patterns throughout our solar system. Jupiter's giant, the Great Red Spot. Imagine a storm so vast that it could swallow Earth whole. This is the Great Red Spot, a swirling vortex of reddish-hued clouds that has been a prominent feature of Jupiter's atmosphere for centuries. First observed in the 17th century, this massive storm is a testament to the gas giant's turbulent and dynamic atmosphere. The Great Red Spot is an anticyclone, meaning that its winds rotate in the opposite direction to Earth's hurricanes. This high-pressure system churns at speeds exceeding 400 miles per hour, whipping up clouds that tower over 5 miles high. The storm's distinctive reddish color is thought to be caused by the presence of organic molecules in its upper atmosphere. While the Great Red Spot has been raging for centuries, it is not a static feature. Observations have shown that the storm is slowly shrinking, and its shape and color have also changed over time. Scientists believe that these changes are influenced by the complex interplay of atmospheric jets and eddies that surround the storm. Studying the Great Red Spot provides valuable insights into the dynamics of planetary atmospheres. By observing how this massive storm interacts with its surroundings, scientists can refine their models of atmospheric circulation and gain a better understanding of how energy is transported within Jupiter's tumultuous atmosphere. Saturn's hexagon, a geometric mystery. Saturn, the ringed jewel of our solar system, harbors its own share of atmospheric wonders. Perhaps the most intriguing is the hexagon, a six-sided jet stream at the planet's north pole. First observed by Voyager in the 1980s, it has captivated scientists ever since. Unlike a hurricane, it is a stable atmospheric wave pattern. Winds whip around its perimeter at over 200 miles per hour. Scientists recreate hexagonal patterns by rotating fluids at different speeds. The exact mechanisms maintaining Saturn's hexagon remain a mystery. Neptune's dark vortex, a fleeting spectacle. Even distant Neptune, shrouded in perpetual twilight, experiences its own version of massive storms. These storms, known as dark vortices, appear as dark, oval-shaped features in Neptune's bluish atmosphere. Unlike the long-lived Great Red Spot, these storms are relatively short-lived, typically lasting for a few months to a few years. Dark vortices are high-pressure systems similar to the Great Red Spot, but much smaller in size. They are thought to form deeper in Neptune's atmosphere than their counterparts on Jupiter and Saturn. As these storms rise to higher altitudes, they create clearings in the surrounding cloud cover, revealing the darker layers below. The exact mechanisms that trigger the formation of dark vortices are still being investigated. However, scientists believe that they are related to the interaction between Neptune's internal heat source and the planet's rapid rotation. The storms are often accompanied by bright, high-altitude clouds, formed as air is forced upward and its constituents freeze out. Neptune's dark vortices, though fleeting, provide valuable insights into the dynamics of a planet's atmosphere. By studying their formation, evolution, and dissipation, scientists can learn more about the transport of heat and energy within Neptune's atmosphere and the factors that influence weather patterns on this distant ice giant. Universal swirls. From Earth's hurricanes to solar system storms, nature's power reshapes landscapes. We've seen the beauty and chaos driven by universal forces. From Jupiter's great red spot to Saturn's hexagon, storms are universal. They reveal atmospheric dynamics driven by heating and rotation. Studying them connects us to the cosmos. Understanding these forces reveals the balance sustaining life and the diversity of worlds beyond. The quest for knowledge. The quest to understand hurricanes is a journey of scientific exploration. With every storm we track, we come closer to unraveling their secrets. Our understanding has evolved from the days of unexpected devastation. Today, we have eyes in the sky providing crucial information, but the journey is far from over. Hurricanes remain complex and dynamic systems. The quest for accurate forecasts continues to protect lives. Exploring hurricanes deepens our understanding of the universe. The quest for knowledge is an ongoing journey. Thank you for joining our Hurricane Odyssey, both on solid ground and beyond. If you found this exploration illuminating, like this video, subscribe to Did You Know, and share your thoughts in the comments below. Whether contemplating the swirling tempests here or dreaming of the solar system's distant storms, let's continue to seek knowledge and embrace the wonders of weather both near and far. As we reflect on these powerful phenomena, we are reminded of the interconnectedness of all atmospheric forces, whether they hold sway over our daily weather or reign as ancient titans on other worlds. Until our next adventure into the realms of science and mystery, remember to keep looking up, and maybe pack an umbrella just in case.